Okay, so today's aim is how do we prove a quadrilateral is a parallelogram? So before we begin, let's review what the properties are of a parallelogram. So the definition of a parallelogram is a quadrilateral, four-sided figure where both pairs of opposite sides are parallel. That is the definition. What are some of the properties that we discovered, which are also theorems? Number one, that both pairs of opposite sides are congruent. Okay, so both pairs of opposite sides are congruent. Another theorem that we discovered, which is another property, is that both pairs of opposite angles are congruent. So one has to do with sides, the other has to do with angles. A third property is that the consecutive angles, and I spelled consecutive wrong, there's an extra E in there. Consecutive angles are supplementary. And the fourth property is that the diagonals bisect each other. Okay, so we know that if a quadrilateral is a parallelogram, all these properties are true. Now the question is, what about the converse? In other words, each of these are theorems. Each of these are theorems. Theorem, both pairs of opposite sides are congruent. Both pairs of opposite sides are congruent. What is the converse of this statement, and is the converse true? Well, first, let's see if we can remember what the converse is. What is the converse? The converse of a conditional statement is you switch the premise and conclusion, right? So a conditional statement has a if premise, then conclusion. Right? So when we take the converse, so the converse of the conditional, the converse says, take the conclusion, make that the premise, take the premise, make that the conclusion. So it's if conclusion, then premise. And the question is the converse always true? So let's take a conditional statement. Let's take one example. If it's a cow, then it's got 4 legs, right? It's true. If it's a cow, it's got 4 legs. This conditional statement is true. What is its converse? The converse is, right, the converse of this statement is if it's got 4 legs, then it's a cow. And we obviously know that that is not true because it can be a dog, it can be a giraffe, it can be a cat. So the converse is false, right? So we know that the converse is false. Let's take another example where the converse is true. If 2 lines are parallel, then they never intersect, right? If you have 2 lines that are parallel, then they never intersect. The converse is if 2 lines never intersect, right? Here I have 2 lines that never intersect, then they are parallel. And we know that that must be true because that is the definition of parallel lines, 2 lines that never intersect. But let's take an example where the converse is false. For example, if two lines are perpendicular, then they intersect. Okay? And we know that that's true. Look, here I have 2 lines that are perpendicular, they form right angles. Then they intersect. That's absolutely true. What is the converse? The converse would be if 2 lines intersect, then they are perpendicular. Is that necessarily true? No, that is false. That is definitely false. What's your counterexample? In this case up here, we came up with a counterexample of a giraffe, a dog, or a cow. So if it's got 4 legs, it's not necessarily a cow. It could be any one of those other animals. What is our counterexample here? Well, our counterexample is, there's a counterexample. Here's line 1. Here's line 2. Here I have 2 lines that intersect, but they are definitely not perpendicular, right? This is an acute angle over here, and this is an obtuse angle over here. So let's go back to our original statement. What is the converse of each of these statements, and is the converse true? Well, what is the converse of the definition? Well, the converse of the definition is if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. Okay, if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. Well, of course that's true because that is the definition of a parallelogram. A parallelogram is a four-sided figure where both pairs of opposite sides are parallel. So yes, yes, and why? Because that is the definition of a parallelogram. Let's take a look at another example. Here's another theorem that we've learned. If both pairs, we know that if it's a parallelogram, both pairs of opposite sides are congruent. Both pairs of opposite sides are congruent. So what is the converse of this property? Well, the converse of this theorem or property is if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Is this true? Well, let's see. Let's investigate that. So I'm going to create a quadrilateral where both pairs of opposite sides are congruent, and let's see if that's a parallelogram. So let's see if we can draw ourselves a nice parallelogram, and there you go. I'm sorry, a quadrilateral. This is a quadrilateral. As a matter of fact, you know what? I'm going to delete this because it looks too much like a parallelogram. I'm going to create a quadrilateral, a four-sided figure. This is a four-sided figure. And what are they telling us? A, B, C, D. They're saying that if both pairs of opposite sides of a quadrilateral are congruent, does that make this a parallelogram? That's the question, right? So if both pairs are congruent, so AB is congruent to DC and AD is congruent to BC, how do I know that ABCD is a parallelogram? Many of the proofs that we do have to all go back to triangle congruence. So what I'm going to do here is I'm going to draw a diagonal from B to D. So BD is my diagonal. What is my plan? If I can show that these two triangles, namely triangle 1 and triangle 2, triangle BCD and triangle DAB, if I can show that these two triangles are congruent, then I will know that all their corresponding parts are congruent, including their corresponding angles. And if that's true, then something else must be true. Then this must be a parallelogram. Let's see what we're talking about. So first of all, how am I going to show that these two triangles are congruent? Well, first of all, I know that DA is congruent to BC. That is given. And I know that AB is congruent to DC. That is given. Remember, the converse statement was if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And I'm trying to see if that's true. Well, that means I have a side here, a side here. That's great. I have another side here and a side here. Well, side-side is not a proof of congruence, and I know nothing about the angles, but I do know that BD is shared by both triangles. Well, that would mean that triangle 1 and triangle 2 are congruent because of side, 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 right? This is the third side that both triangles share. Well, if that's true, what else is true? Well, it is true that these two angles, namely angle CDB and angle ABD, these two angles are congruent because of corresponding parts of congruent triangles are congruent. Remember, if I take this triangle, triangle 1, and I rotate it around this point right over here, these two angles are going to coincide, and they are congruent. Well, what does that mean? If those two angles are congruent, what does that say about lines AB and DC? Well, not only are AB and DC congruent, AB and DC must also be parallel. Why? Because it says that if alternate interior angles are congruent, then the lines, namely these two lines, cut by the transversal, which transversal? This transversal, BD. Then the lines cut by the transversal must be parallel. So these two lines are parallel. Well, what else do I know? I know that these two angles over here, namely CBD, angle CBD, and angle ADB, are also congruent. Remember, I'm rotating the bottom triangle, triangle 1, around this point over here, and angle CBD and triangle ADB are going to coincide with each other. Well, if that's true, what does that mean about DA and CB? Here I have another example of, and I will do this in blue, I have another example of alternate interior angles that are congruent to each other, which means that line segment DA and CB that are being cut by the same transversal DB are not only congruent, which is given, they are also parallel to each other. Well, if that's the case, if both pairs of opposite sides are parallel, what kind of quadrilateral is ABCD? Well, it must be a parallelogram. So let's take this down in our notes. So theorem. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Put your player on pause, take down the theorem, take down this diagram, and take down this diagram, and when you're done, hit play to resume. Okay, let's do the proof. So this is going to be the formal proof as a statement and reason. Here we go. So, statement, reason. Given AB is congruent to CD, and they denote that by individual hash marks. BC is congruent to AD, they denote that as well. Prove ABCD is a parallelogram. So first order of business is, let me say that BC and AD are congruent. So line segment BC is congruent to AD. It doesn't matter in which direction, in which order I put this. So AB is congruent to DC, and line segment AB is congruent to CD, and the reason for that, of course, is given. That's really nice because now I have two sides, side and side. Now, second thing I'm going to do is, because there is no diagonal here, I'm going to draw one. Okay, so I am going to draw diagonal AC. Reason for that? Construction. I can draw whatever I want. I can draw a smiley face if it helps me do my proof. Okay, well, what does that mean? Number 3 is line segment AC is congruent to line segment AC. Reason for that? The reflexive property. Reflexive property of congruence, or a reflexive property. Well, hey, I've got another side. So what can I say now? I can say that triangle ADC, which is this triangle right over here, and remember, A in ADC corresponds to C in ABC, right? So I will say triangle ADC is congruent to triangle CBD, and the reason for that is the side-side-side triangle congruence postulate. Well, that's nice, because now what can I say? Remember, if two triangles are congruent, all their corresponding parts, including their angles, are congruent. So what I can say now is that these two angles, namely triangle DAC and BCA, are congruent, right? Because of corresponding parts of congruent triangles are congruent. So I will say now that angle DAC is congruent to angle DAC BCA, angle BCA. And what else can I say? I can glob these all together. I can also say that these two angles, namely angle DCA and BAC, I can say that angle DCA is congruent to BAC, angle BAC. Both of those have the same reason. Corresponding parts of congruent triangles are congruent. CPCTC. Well, if that's the case, what can I conclude? If both pairs of alternate interior angles are congruent, then what can I say about BC and AD and AB and CD? Well, I can say that AB is parallel to CD. AB is parallel to CD. And what else can I say? I can say that BC is parallel to AD. BC, line segment BC, is parallel to line segment AD. BC is parallel to AD. Why? Because of the alternate interior angle theorem. I would actually say the converse of the alternate interior angle theorem. Well, wait a second. If both pairs of opposite sides of a quadrilateral are parallel, what does that mean? Well, ABCD must be a parallelogram. ABCD is a parallelogram. Why? Because both pairs of opposite sides are parallel. And we are finished. And you're going to make sure you take this down in your notes. If you need to, put your player on pause and make sure you take this down, each and every statement, because you need to know each and every statement. And I hope that helped.